Tonight we discuss buoyancy, how to make things float. I remember learning about this in high school in my science class, but it's been many years since then, and I had to do a refresher course on the internet, and I think I learned everything that I need to learn about it. Please note, I did not say that I learned everything there is to know about buoyancy. I said I learned everything I need to learn about buoyancy. Sufficient for my needs. So buoyancy is essentially upthrust, or it's a force that pushes up. If you want to get Wikipedia scientific, it is the upward force exerted by a fluid that opposes the weight of an immersed object. So I'm sure that every person on earth that has ever been in water with like floaties or a tube or a ball or whatever, and you push it underwater, you could feel it fight you back. Or you've sat in a raft or whatever, and obviously you don't sink, you're up. So it's the force that's pushing up that makes it so you don't sink when you're sitting on water or in water. So that's what buoyancy is, but that doesn't do much for you unless you know how to calculate it. A certain man named Archimedes, about 250 BC, came up with this principle, which is this. Upward force, whether the body is fully or partially submerged, is equal to the weight of the fluid that the body displaces. I will repeat that one more time. The Archimedes principle states that the upward force in buoyancy, whether the body is fully or partially submerged, is equal to the weight of the fluid that the body displaces. To help make sense of that, in America, we're pretty familiar with gallons. You have a gallon of milk, you have a gallon of water, you have a 5-gallon bucket. We measure kind of everything in gallons. So let's use a gallon as our basic measurement tool. Let's move to the paper. Alright, so 1 gallon of water equals 8.34 pounds. So if you've ever picked up or purchased whatever, a gallon of water from the store, that's how much it weighs. So if I pushed an empty 1 gallon container into the water, that 1 gallon container could hold 8.34 pounds before it sank. I weigh about 180 pounds. I don't know how much my finished product is going to be, so I'd say the bare minimum that I would need to support with my floats is 250 pounds. Bare minimum. And remember, I don't want to get my feet wet when I'm pedaling, so I'm actually going to shoot for 300 pounds. Just to be safe. So I know I'm not going to sink, and I know I can keep my feet out of the water. So I have to support 300 pounds, which means I need to displace 300 pounds of water with my floats. I need to determine how big my floats need to be to support 300 pounds to displace 300 pounds of water. So I'll divide 300 pounds by 8.34, and that will give me how many gallons I need to displace. And that comes to 35.97 or 36. So I need to displace 36 gallons of water if I want to be able to hold 300 pounds out of the water, if I want 300 pounds to float. I don't know if this is a true quote or not, but Adam Savage, the guy on Mythbusters, I saw a meme that said that he said this, so it's got to be true. Said that the only difference between messing around and science is writing it down. If that's the case, then I am becoming quite the scientist. You may formally refer to me as Doc Bomblewood, if you want. Anyways, 36 gallons to displace is not very much. I was planning on using 55-gallon drums, just because that's what is really common to find to make my floats. One 55-gallon drum would hold 458.7 pounds out of the water. That is overkill. If your family lives in a flood zone, you don't need more than 2 barrels to float your family to safety. get like 900 pounds of float power in 2 barrels. So throw that in your emergency preparedness kit. Flood zone livers. Anyways, I'm actually very happy about it only needing to be 36 gallons displaced, because that means my pontoons or my floats don't need to be very big. They can be pretty lightweight, and you know, I can cut them down to whatever the heck I need them to be, because I only have to displace 36 gallons of water to keep me afloat, comfortably keep me afloat. So that's good news. I'm no teacher, so you may want to go double check if you're using this as a source to learn about buoyancy. I learned it from Wikipedia. Can't go wrong. It's not true. I double checked in several places. Confirmed Wikipedia was correct. I now know exactly how big my floats need to be to keep me out of the water, which is important because I don't want to make them oversized and create more drag and more weight and more everything, because I'm trying to win a race here. So it's important to have the minimum calculations so that I can go faster in the water. Now that I have done these calculations and I know how much I need, I can find materials that are suitable, and I don't have to buy more than I need. I don't have to find more than I need. I don't need very much. 36 gallons is going to be easy to do. The hunt begins for materials. I have to find them. I have, for the most part, things figured out, so I'm the only thing that's holding me up now is my lack of materials. So I got to get on it. I got to find that stuff, and I got to find it for cheap, because I have barely any money. $30 to build the rest of this thing. Wish me luck. Please!